Ja, roept hij wat mensen staan? Dus jullie gaan intro-taal. Ik ga een intro-taal doen.
Denk je dat iedereen genoeg heeft? Anders, ja. Heeft iedereen genoeg gegeten? Anders zouden we de pasta opruimen. Als er nog iemand is, ga gerust. Iemand? Oké.
Ik heb er nog redelijk veel aan.
Is dat zo? Ja, dat geef ik zoiets.
Welcome everyone at the Flutter Belgium Meetup number 15 already. First time in West Flanders. We're very sorry it took us so long to get all the way over here, but we're very happy that we finally managed to get here. I think first things first, thanks a lot to Make It Fly for hosting us here, especially that we finally made it to West Flanders. I think Delphine will to say a few words for a second.
Hello everybody, thanks for coming. We're very happy to host the Flutter Meetup this evening. I just heard that it's an English session, so sorry I didn't really prepare a response introduction in English. Maybe a quick introduction who Make It Fly is. We're a digital solutions group consisting of 5 brands and in 4 locations spread over Belgium. Bruges is one of those locations. We offer digital solutions, of course, to our customers, ranging from digital strategy to marketing to, of course, also development. Flutter is also one of the expertise that we have here at Make It Fly. If you want to hear more, I'll be at the bar. If you want to drink or just find out more about Make It Fly, just let me know. Enjoy your evening and thanks a lot for coming.
Okay, then the usual announcement. So first of all, Flutter Belgium, for those who are new, who's Flutter Belgium? That is Chris, who's sitting right there. It's me and it's Koen. We started organizing these meetups in 2018 already, basically to start to create a bit of a community around Flutter to make sure that we can all learn from each other, give talks, and I think since then we've grown to almost 700 members now, so that's quite good. You can join us. We have a Slack that you can join where we share technical tips, we share stuff about the meetups, we share videos from the meetups so you can rewatch them later. If you scan the QR code, you can join. It's also on the slides. And then the usual announcements. We can only keep these things going if we have locations and speakers. And locations, they're usually not too hard to find. I think we have plenty of companies that are willing to host us, but we really need people to speak. So warm call for speakers. We have actually on the Slack, you can also just request topics. If you don't really want to speak yourself, feel free to request a topic because maybe there's somebody else doing something in Flutter with your topic that wants to give a talk about it. It also doesn't have to be mega super advanced topics all the time. It can also just be an introductory into something or into a package that you first worked with. If you don't want to do a full-length talk, usually we don't have some today, but usually at the beginning of our meetups, William gives a lightning talk. But everybody can give lightning talks. They're just like 5-10 minutes, no longer than that. It's just something that we stumbled upon, that we saw. That's also very welcome. I think if you register for the meetup, you get like questions. You want to give a lightning talk. So if you want to, by all means, you don't have to prepare much. Just like come up, talk. It's always nice as a first experience, maybe. So we have these topics. Chris checked gRPC for today, but we're still looking for talks on Flutter Web, Flutter App in App. These are topics that have been requested by the group. If you have other topics, feel free to share or reach out to Koen, Chris, or myself if you want to give a talk. Or host, of course, that's also always welcome. Our program for today, we have Frey giving a talk, and then we also have Chris. And then, this is new, we have a raffle now. So, because we're an official Google Meetup group, Google sends us all sort of swag, Flutter related. So we have some dashes, we have t-shirts, we have stickers, and we can raffle them off now. So if you scan the QR codes, Koen did an effort over the weekend and last night to quickly build a raffle app. So at the end of the meetup, we'll raffle off some goodies, hopefully. Yes. I think the QR code on the banner is always is also to join the raffle if the slide is gone and you start to join.
So you have to log in with Meetup. As of now, we're maybe trying to also add Google, but you have to go through a review process, of course. I've had 2 issues with login, so if you have an issue, just come to me during the break, and I will explain what you need to do. But normally it should work fine if it doesn't come to me.
And yeah, we have no lightning talks. Maybe already quickly, but this will be up in the end. The next meetup is in Hasselt, all the way at the other side of Flanders, at ACA Group, 24th of January, just so you know. And then I think there's one left. All yours.
Yep.
Yes.
Before I start, I didn't prepare a lightning talk or anything, but if anybody doesn't know about it, next week is the start of Advent of Code. Two of you have heard about Advent of Code before, so let's say half the room. Definitely go look it up. It's actually some sort of competition where you get, every day you get like a riddle that you have to solve. You can solve it with code, you can choose to solve it with Excel if you want. But you just have to submit an answer to it. It's a fun thing towards Christmas, and it has like a whole storyline just look it up at adventofcode.com and you can join. So definitely I hope to see a lot of people joining using Dart as their preferred programming language for that. All right. Welcome everyone. Today I want to talk to you about a project that we did here at Make It Fly a few months ago, where we chose to use Flutter as our solution to create real-time bus displays for the new shuttle buses that tour the city center of Bruges. First of all, this is just going to be like a story today. So I'll give a brief introduction, I'll set up the story a bit to get everyone in the mood of the tale. Then we'll go to some technical stuff. There is going to be like a couple of interesting stuff in between, hopefully. We'll have an exciting twist near the end, and then hopefully the story will come to a happy end. But first of all, I'm going to introduce myself. So my name is Fee. I was a developer at Make It Fly. I actually gave this talk already in Prague at F3. And since then, something changed. I actually went on a different path. Freelancer right now. I live here in the city of Bruges, where this project takes place as well. And if there's anything I can say, I'm just a Flutter enthusiast. So, let me first tell about about these shuttle buses that we have right now in Bruges. Maybe some of you saw them drive by here. Nobody? Somebody? You did? Perfect. So what actually happened, as you all are aware of, a lot of things are changing in mobility these days. I think near the summer, the lane decided to completely overthrow like their current schedules and change everything. And with that, there was a possibility for the city of Bruges to improve their mobility as well. So they checked how they could make transportation within the center of the city a lot better. And they sat down together with the lane and decided to only have a few buses from the lane pass through the city center. Now, to accommodate other people living in the center and still get everywhere, they chose to have their own free shuttle buses that continuously tour the city. For this, they partnered up with Keolis. Keolis is a worldwide mobility provider. And at that point, they were already a client of Make It Fly for several types of projects. And then they came to us with a question, because to do this project, they needed to have onboard displays that show which stops are going to be next. And they didn't have anything ready yet. So when they came here, they actually came here for a different project to talk about that as well. And then he mentioned, like, yeah, we actually have this contract with the city. We need to have some sort of solution there. Can you help us? And we were like, yeah, this is something cool. This is something interesting. It's something different than a normal app or a website. Yeah, we're definitely fan of that. And we asked, like, okay, when should this be ready? And I don't know if this is an exact quote, but this is what I remember. So basically, we only had about 2 weeks to get this done. Eventually, as a side note, there was some more time because there were some other hiccups in the delivery of the buses and so on, so it gave us a little bit more space. But we dove into this project with this in mind, that we only had limited time to deliver the product to the client. So I've been talking a lot about it. Let me first quickly show what it is. So in these little buses that tour the city, they have these displays. They're quite simple, but they explain just at which stop they are, which is going to be the next stop, and so on. Here's a small visualization of where these buses go. Since beginning of this month, it takes a little bit larger course. And yeah?
Side question.
Yeah?
Because I depend on public transportation.
Okay.
You mean that in all the center of Bruges,
Yeah.
this is the only thing to move around?
No, there's 2 other buses of the lane that are going through the center, and there you can easily switch off to those shuttle buses if you need to get somewhere specific. They actually decided to have less of the big buses of the lane going through the center, because before it was all of them basically, which is quite like disturbing and making a lot of noise within these small streets that have these cobblestones and everything. So they want to make it better like this. I have a short video, but I didn't test the audio. The thing is, there's a small spoken announcement as well every time they're leaving a bus stop again. So with this project, of course, there were a few challenges that came to be. First of all, we had to provide real-time data. It has to be updated when the driver leaves a stop, when it starts again when it stops at a certain bus stop. Another challenge were these announcements that have to be made. So also for the visually impaired passengers, they have to know which stop is coming up. And of course, to make it scale, we wanted to have over-the-air updates. Even though that they pass by the office, it shouldn't be the case that we have to get on board and fix stuff, which may or not happen a few times. But when thinking more about this, definitely the state of the city with these cobblestones, we also had some physical challenges for this, because you cannot just put any type of device in there. And when we started the project, we didn't know what we were going to run on. We didn't know the platform. Was it going to be Android? Was it going to be maybe an Android TV that is going to support this? Maybe, who knows? But is it going to be strong enough to hold these physical challenges? Another common solution for this is using a web-based solution. There are several providers of these displays that use web. Others use Windows or Linux. But at that point, we just didn't know. We could have gone for an embedded solution as well, but we didn't know, so we just chose Flutter, because we could defer the choice of which platform to run on. Meanwhile, we could start building already. So we also came up with some hardware solutions for all of these challenges. Eventually, we chose to go with an industry standard screen that is seen in a lot of buses and trains and all these types of transportation systems. I don't remember the name exactly, but it was their main business. For the audio, we decided just to use the audio of the bus, because these monitors that these companies provide, they just care about visualizing stuff. They don't care about having a sound system in there. So we just said, okay, what if we just use the onboard radio? And we checked, could we have something with an audio jack? And this should have been not displayed yet to keep it as a surprise, but we went with the Raspberry Pi.
Did you go with the CM version or the normal version?
I think
The
just...
one in the picture or the one that
Yeah, we went with this one just to be sure. We actually went for a Raspberry Pi Model B, the fourth generation of it, with way too much RAM because we just didn't want to risk it. We only had 2 weeks. But the Raspberry provides all the necessary connections that you need. It's relatively cheap. It can easily be tucked away somewhere. And you can run multiple types of operating systems on it. So even then, choosing this hardware, we were still flexible in which type of platform we want to support with Flutter. So I think we had a few solutions that we thought of, and one of them is to use Flutter for embedded devices. But at the moment, it's still in a very early stage. Even if you read the documentation about embedded Flutter, it says that just like this line here is not for beginners. It's just they don't have a simple solution yet because you have to work with low-level APIs. And if you only have a short time frame, this is not something that we wanted to dive into at the moment. If you are interested in using Flutter on embedded devices, you can check out these community solutions that offer custom embedders that work on the Raspberry Pi. But a side effect of that might be that you also won't have a lot of plugin support. You can use packages and so on, but maybe not all types of plugins are supported. Then another solution that I was thinking was, okay, can we use just Flutter on a Raspberry Pi that is just running Linux? Because Flutter is completely available for Linux for desktop. But it is still quite tedious to set up. I thought until this morning when this article came out, which actually gives a video of how you can connect your Raspberry Pi to your development machine and just run directly on the Raspberry Pi. How this actually works is it's just using the Raspberry Pi OS, which was previously known as Raspbian, which is just a Debian distribution. It runs that on the Raspberry Pi and runs Linux Flutter apps on there. This is actually done by a company called Snap Embedded. Maybe for the people that were at FlutterCon in Berlin and saw the talk about making coffee with Flutter of Moritz Thijs. This is his company. He is focused on just making Flutter a lot more easier for embedded devices or any type of other devices. So, and with this, you can actually just use hot reload, you can use the dev tools. It would just be like developing on a mobile device. But then we were looking for still another solution. So using Flutter on Linux on the Raspberry Pi still was tedious at that time. And when I was looking which type of operating system I could install on the Raspberry Pi, I just went through a list and my eye fell on this one called Full Page OS. You can probably guess what it does already. It's just a distribution that opens up a Chromium browser the minute it starts up. You configure it with the URL it has to fetch, and you give it some network configuration so it knows which Wi-Fi to connect to and so on. And then it just does that. So eventually we chose to go with this and chose to build Flutter for the web. Definitely check it out. It's a super useful package if you just want to create a simple kiosk application. But the web still has some issues. Has some people of you already developed with Flutter for web? We have a few hands, nobody is super convinced. And I agree. It is very nice to have that option, but it can be tedious to develop in it. And definitely the case around hot reload. Hot reload is not working on Flutter for web at this moment. So you can only use hot restart, so every change that you push takes you back to the beginning of your app. And if you have complex apps, you have to go through the whole process again just to make the small UI change. Luckily for us, it didn't matter, because this is just a one-pager and it doesn't manage its own state. It fetches it from somewhere else and listens to the stream of new data coming in. So we didn't have this problem. This didn't hold us back. But if somebody wants to develop something for Flutter for web, it might be good just to try to develop on desktop, even if you're not going to publish on a desktop application, because it just gives you a large screen and you can just easily use the advantages of hot reload and then eventually run it on web, see if there's still any difficulties and solve it that way. I think it will boost up your development speed a lot. There's some other issues that you might have. Playing audio is not as easy as you might think, and definitely not in a browser these days, because Chrome and Chromium, they require you to interact with a page before it can automatically play any type of media. The problem is these are just these screens hanging there somewhere. We cannot ask the passengers like, yeah, tap it first and then it's going to be fine. But luckily, there's an option in Chromium. You can just say, okay, do the autoplay policy to no user gesture required, and then it's all working fine. Unfortunately, this was not available in full page OS at that time. And at this point, I was thinking like, okay, should we move to another platform? Should we go for Linux apps? Because we can still move. It doesn't matter yet. And I came to look back the next day, and I don't know, this was kind of a miracle to me, but somebody submitted a pull request on the next day to address this issue, which was probably there for months already. So there was a fix, and even by the time that we had to move to production, it was already available in the nightly builds of full page OS. So we were able to use that and not spend any more time thinking about how to play this audio. Now we have everything set up, but where do we get the data from? Because these buses are driving around the city, they need to know where they are, they need to know how to update the data. And back in 2019, I think, we started on the development of KeoCount. KeoCount is another product that we made for Keolis, which is actually an assistant app for a driver. It shows the next stops and when they have to leave those stops and so on. And they initially made this for collecting some data about which types of passengers get on and off which types of bus stops. So it was mainly focused around collecting events about the routes these buses take, so that they could optimize it. Now, other than events like a passenger got on and off the bus, they also collected the events of the bus started driving, the driver arrived at a stop, they leave the stop again, and so on. So we were able to use those triggers to update our screens. Now we got lucky also because these events were actually never made to be sent in real time. But on Android, if you have an internet connection and it was powered to a power supply, it would actually just upload all these batched events immediately, and it only took about 2 seconds for an event to actually reach the server, which was fast enough in our case. We also provided these tablets with SIM cards so they would have this constant internet connection. Now everything, I explained a lot of different components. I'm gonna show them all in a scheme together just after this. I want to talk about how we use Firebase for this. I think most of you all know that Firebase and Flutter are a match made in heaven, if I can say it like that. It just works super easy to get it something started. And for this project, we chose to use Firebase hosting just to host the web application that is running on the screens. It was very easy. They provide you with a URL that we didn't actually have to change because it's hidden anyway. So we could use that. We didn't have to go to DNS configurations and so on. Again, this is all had to be done in 2 weeks, so we didn't have a lot of flexibility there. And if we're talking about real-time data with Firebase, of course, we're thinking about Firestore. So Firestore kept all the data of each bus that needs to be tracked, so it can just listen to those new updates. And the last product that we use were Cloud Functions. Cloud Functions in Firebase allow you to easily create HTTP endpoints as well, which made it a lot easier to update the state of Firestore there than doing that in the backend that we already have. Our backends were written in PHP, which doesn't have official Firebase SDKs. There are some community solutions, but we didn't want to dive into those at the time because of the time constraints. So putting this all together, because I explained a lot of different systems, when it actually starts, when the bus gets its power, the Raspberry boots up, it connects to the Wi-Fi that the tablet is actually emitting through a hotspot. Then it goes to fetch the web application. It shows that one on the screen. It then goes to Firestore, because in the URL that we predefined on that specific Raspberry Pi is also an identifier of that bus. We just use the license plate number. It's an easy identifier, and like that, it gets streamed updates about where this bus actually is. Every time it gets an update, we update the screen. And then when the driver uses his assistant app that was sitting there, these events get transmitted to the backend. And at the backend, we just send a state update towards Cloud Functions. Cloud Functions updated the Firestore for that specific bus, goes back to the Raspberry Pi, goes on the screen, and eventually gives an announcement which stop is going to be addressed next. So this is how everything came to work out, where we worked with existing components such as the Kio Count app and just tried to get something up and running. So, and it was working. Hooray! Just to give an idea, I think this was after about a week of development. So we just put all the pieces together, and it worked, and we were happy because it worked at the office. And I think that's where we get into the second part, which was actually the last week. There was some time in between, but the buses still needed to be assembled. They needed to come to the city of Bruges, because I think it were Turkish buses with German engines assembled in France that had to be used here. So it's a whole thing. And eventually, this was the last week of June. On Tuesday, the buses arrived, and we were able to go there and install the Raspberry Pis. And I remember going there. We got on the bus. We checked, like they nicely put all the necessary connections together. So I hooked them up, and we tried out, and we don't see anything. And I'm curious, like, okay, is the electricity on? Yeah, everything else seems to be working. And so yeah, we're trying to figure out this problem. And as a developer, I thought, like, yeah, maybe it's this bus. So let's go to the other bus with the other Raspberry Pi. And meanwhile, on the first bus, they're calling the people in France, like saying, like, yeah, is something wrong here? What's going on? And I go to the other bus. I take the power cord. I put it in the Raspberry Pi, and I'm like, oh yeah, it works. There's a light here, and smoke. And that's when we realized that they actually hooked up the power cords to 12 volt instead of 5 volt, which completely fried the Raspberry Pis in the week that we had to ship. So that became quite exciting, but we were able to order new ones, which isn't always that easy to get Raspberry Pis delivered fast enough. In the meanwhile, they fixed this problem. The Thursday evening, we went back, installed them, and it worked. So Friday, we do our first production test at the press conference. But everything was working seamlessly. It was a bit of a scary moment sitting next to the mayor while this is actually being tested for the first time completely. But everything turned out great, and since then, the next day was the start of this shuttle bus service. And you can still see them go around. I think I just saw one pass. But anyway, we were able to help the client on such a short time using Flutter and Firebase as well. There are a lot of things here that in a normal development process, we would say like, don't do this. And I think there's room for improvement. And we know this. One of the things is like right now, we require manual actions to update these displays. These can be replaced over time by GPS. But again, if you only have 2 weeks and you literally have 1 day to test how the GPS signals are in a historical city, we didn't want to risk that at that time. Another one is that there's a 5-second delay by the, if we count from the time that the driver enters the action and the screen is updated. It's okay, it works. It's only 5 seconds, we can live with that, but there's room for improvement. And there could be other stuff. We could actually have the tablets send a direct signal to the Raspberry Pi instead of going through Firestore and so on. These are all improvements that we can make along the way. And one of the most crucial things is that the drivers cannot listen to the car radio. And so what we noticed is we had people saying like, we cannot hear the spoken announcements. And okay, I was like, okay, let's get on the bus at the bus stop right here, like debug in production. And then you just see that he's just listening to his own music. And it's like, yeah, that's something that we knew coming into this project. It was just going to be too much work to set up a whole audio system, but again, we can make that work later.
This 5 second delay, is this every time or is this up to?
It's about every time. It's quite consistent.
Any idea where the delay is coming from?
Yeah, I think it's in several places. So first of all, we have these batched events. So if I said like it takes around 2 seconds to be on our server, then there it has to go through Cloud Functions. Cloud Functions has to go to Firestore. That one has to go back to the Raspberry Pi, which also relies on the Wi-Fi connection of the same tablet. So there's a lot of possible hiccups. So if we can make this a little bit shorter, then I think we can make that better. Let me just go back to this screen actually. If we would be able to just go from here directly to the Raspberry Pi using maybe MQTT or another type of protocol, yeah, that could be resolved, I think. But again, it works for now. We can improve upon it step by step. Now, we were here. One more thing. It takes a lot of initial setup, definitely, because you have these tablets. They have to have those credentials on the hotspots. They need to have SIM cards. The Raspberry Pis need to be configured per vehicle. So those are also pain points that can be worked at in the near future. But it has a lot of advantages. One of the advantages is that we're still flexible on which platform to support. We can still switch to Linux for desktop and make this experience a bit faster if you want to step away from web-based solutions. The biggest one is definitely that we took a very pragmatic approach here. We just focused on which result we wanted to have and not specifically about, yeah, we shouldn't do this, or we just said, okay, does it work, and does it work reliable enough? And the last one, which I think is very important, for the 3 products that we built, or the 3 app products that we built for Keolis, we're using Flutter in all of them. So choosing Flutter also for this project allows us to have developers that know about the domain of Keolis and can easily switch between their different products. If we would have gone with another technology, we would have needed a different person to work there who isn't familiar with the Keolis domain. And that's all I have to say. If you have any questions, I would say shoot, I can answer them right now. If not, you can still ask me later tonight.
Thanks for the talk, really nice talk. For the raffle, I used Firebase as well.
Yeah.
So I know how fast you can prototype and
Yeah.
get something out there.
Definitely.
You said indeed for installing the Raspberry Pis, you need to do that, of course, manually.
Mm-hmm.
Do you have to do something else after everything is set up on the bus? So let's say you need to do an update. Do you have some configuration to do on the Raspberry Pi
No.
for a next release or something?
Not specifically. So all the configuration is already done. So the Raspberry Pi just points to a certain URL. If we want to update the application for the displays, we can just easily do that because, yeah, Flutter for Web has the over-the-air updates that way, just like all web applications do. And for the connection of the tablet, going to know on which bus it is, it was already a part of the original key account application. So if the bus driver starts its round, it has to choose, I'm on this bus, I'm taking this schedule, and that way we actually have that information.
Right, thanks.
Yes?
Could you expand on the word tedious?
It is things that Flutter developer don't like to do.
You were trying to put Flutter on the Raspberry.
Yeah.
You were trying to compile a program so that the UI was direct from the Raspberry. Was that the tedious part here?
It's mostly the setup. Okay. Mostly setting up the fact that you need to first set up a Linux environment, run it on that, and you have to, if you want to develop on a Raspberry Pi, you had to compile it on the same type of architecture as well. So if you're working on a Mac, for example, I think cross-compiling there doesn't work. And I think or you can probably make it work, but again, it's not going to be as easy as just doing a Flutter create and then just run it. I think the solution that the people at Snap Embedded made right now, I'm not sure about this, is that they might offer the Raspberry Pi as a target device, but then actually ship over some code to the device itself where it's compiled on that device before it's rendered there. So it doesn't the compilation doesn't happen on your dev machine in that case, which makes it like it's not really cross-compiling, but it feels like it. You're just using your own dev machine. You don't have to think about, I need to compile this on Linux and so on.
Okay.
Yes?
Did I understand correctly that the Raspberry Pi, when you start up, does it fetch the web page over the network, or is it part, do you put the web
It is
page
fetched.
on it is fetched.
Yeah, yeah. Yeah, that allows us to update it.
On Firebase hosting.
Yeah. Exactly. So the thing is, like, if we need to do a forced update, we just ask the driver, like, shut down the car and start it up again. because it takes off away the power, the Raspberry boots up again and just fetches everything again. So yeah, basically.
Did you look into putting the server on the device, on the Raspberry Pi itself?
No, not at that time. To be honest, we were just looking for a fast solution at that time. The server that I pointed out here, it is actually the one that's being used for other shuttle buses as well. So we just wanted to keep that in place because it has another purpose as well, to collect these analytics or these metrics actually. So hosting it on the Raspberry Pi itself would have made stuff more complex, and it could have helped maybe, but at that time we didn't choose to go there. Yes?
Yeah.
Yeah. You said that you were sending data from like the cloud function that initiates it to the Raspberry Pi.
Yeah.
And what does that then do?
So
You're not just updating the web page, or?
let's go back here. So what actually happens, the backend addresses an HTTP endpoint in Cloud Functions, and in Cloud Functions, we parse that request coming in, and then we check in Firestore every bus that should be tracked. This is one of the options that we actually have in the backend of KeyAccount, has its current state and which next stops it has. So this is where it's going to update that current state, and this is all done in one collection in Firestore per bus, and the Raspberry Pi has a streamed connection to that specific Firestore collection. So it just gets updated every time something changes in its schedule. Come.
I'm using a Raspberry Pi for Home Assistant at home.
Okay.
And I have to replace the SD card every 6 or 8 months.
Yeah.
Of course, it's not yet. Yeah, it's not yet so long in production.
Mm-hmm.
So maybe that's something to consider. Or if something suddenly breaks,
Yeah.
Raspberry Pi is known to break SD cards itself as well. So.
Yeah, I think so as well. So when we talked about this project, the client was immediately on board saying this is a proof of concept. We're just going to try this out. So there are definitely some obstacles still along the way, except for like the things that I already discussed. That's definitely one of them. I think the minute we start noticing those issues, we're going to check how to address them. And if it would be the best solution to just replace them every once in a while, then that might be good enough.
Somebody came up with solid state.
Yeah,
Oh,
the
yeah.
next generation of Raspberry Pis, the
Yeah.
5, has SSD support.
Yeah.
Perfect. Problem solved.
Yeah, still prototype, but
Yeah.
it works.
Yeah, I think we should have all been together at that meeting in the beginning. We would have solved this. No, so if there are no more questions, thank you again.
All right, we'll have 15-minute break. I think some people still need to eat. So if that's still possible.
You see? Right.
No? Yeah.
You see?
You can also still enter the raffle.
Ik heb een template gebruikt dat elkaar gevonden. En,
Stel u voor,
Ja, nee.
er komen updates. Hoe zou je dat aanpakken?
Ah, sorry.
yes. Ik kan dat nog niet te luid zeggen, want ik word nog opgenomen. Right. Jens? Hoe sluit ik deze nog?
Nee, niet zo. Ah, wacht.
Ja,
We waren je was uitgevallen.
Uitgevallen.
Je was uitgevallen, ja.
Te lang gesproken.
Ik snap het niet goed, je steekt in.
niet gesproken.
Je steekt in, je moet dan toch wel...
Ah. Misschien. Je weet.
Ja, misschien zoiets, ja.
Ja,
right. When everybody's ready. All right, welcome. I asked ChatGPT one thing for this thing, that was create me a title for it. It was this one. I was okay with it. I liked it, so I used it. I also asked to generate an image for my slide, but it was actually a phone using a USB-A port, which connects to via gRPC to a server. I did not use that one. Was totally wrong. Who am I? I'm Chris. I started as a Java developer, working on an open source CMS system. Also did some web service stuff for Bolero, which is part of KBC. Then I became a PHP developer for Kunstmaan, which is the company I worked for then. Then I switched to an Android developer, did some projects on it, and then I discovered Flutter actually in 2018, and I really liked it. I of course tried React Native and then all the other things that were passed already, but I was sure Flutter is going to be it, and there was no Meetup, so I guess I said, okay, let's create one. And nowadays I'm a Flutter developer for InvestSuite, which is a company that creates software for banks. So in this case, a mobile application or services for that mobile application. And in my spare time, I created the IJsradar. It's a mobile application where you can see where the ice cream trucks are at that moment. An ID and just start coding. I'll give a talk about gRPC. So what is gRPC? It tries to be a cross-platform, open source, high performance, and to do calls on a server from a client or vice versa. But the end goal is actually that the server doesn't have to be the same technology. It can actually do calls like on the client. You just do a method call like you do a normal method call in your code, but actually it's a call to a server, to a service. Here you can basically see what's happening. It's also it's of course via TCP. It says, oh, I want to execute this method, and then the gRPC server will respond with some headers, some data, the response itself, and some headers, which is already a bit different than the normal REST calls, which don't have these ones. A bit of history. In 2001 it started internally at Google and with the name Stubby. They needed to communicate with all their cloud platforms and servers, and they created Stubby. And then in 2008 they released part of the Stubby thing, and they named it protobufs. So protobufs is actually a way to describe the structure of data. And then in 2016, so not so long ago, Google publicly released it, and they renamed Stubby to gRPC, and now everybody can use it open source. They have a lot of support for it. It generates, you have the gRPC spec and you generate code. So for which platforms or which languages can you generate code? All these. I took this image from their website, but it's already, it's outdated because, for example, Swift is also an official supported thing. Maybe to give you an idea of what the alternatives are for gRPC. Of course, everybody knows REST, doing a call, getting a response. Then also GraphQL can maybe be an alternative, where you can, it looks like you're querying a database. You do a query, you get a response. SOAP, if you want to use SOAP nowadays, it's a soup, but yeah. And then there is Apache Drift. I'm not sure if somebody uses it, but it's the most likely almost the same as gRPC, but just a bit different. So part of gRPC is protobufs, defining your API actually. It starts with syntax. It's the version of the protobuf you're using. You can use packages like you can use in all kinds of languages. You can group everything together in separate packages. And then here I defined, as an example, I created a weather info service where you can actually ask, give me the current weather. This is the method call, this is the request, and this is the response. So what is the request? It can be, for example, a postal code. Give me the weather info for this postal code, or a location identifier. So you already see you can define here a one-off. So you can only send one of those two. It defines what is possible or not. And then the message, the response, can be a string, a double, temperature, very dummy booleans. Is it cloudy? Is it rainy? But it can also be another message, for example. So you can nest stuff or reuse stuff. And another possibility is also using an enum, like you have also in code, of course, where you have lots. You can the main thing about protobuf is actually those numbers. Always you can say, oh, this looks a bit weird. The number. Why do I have to count 1, 2, 3, 4, 5? Of course I can do that, but why can't the software do it? But it's actually for a reason. So here you already see one of the reasons. So how does that object convert to data sending over the line? It's a byte array. Here you can see the field number is used, the type of the property, and then the length of the string, and then how many bytes. So as you can see here, everything is sent over the line, but only the thing that is needed is sent over the line. If you compare that, for example, to talking with JSONs, you send always the name. Also, for example, for a number, you send a lot of data over the line, which is can be a big difference. At least if you want to develop for mobile applications, you as a developer, you're working on your computer, internet is fast, but the end user is using an edge connection, then things can be different. What stuff that you can do if you make an API, the server talks with that talks as that API, and you have a client. Of course, you cannot force update applications. In the App Store, you submit, and eventually it got updated. End users will maybe not in a month press the update button because they don't want to do it. Then you have to be sure that everything that you change in your proto specs on the server can still be done, and it's not a breaking change. So what is here a breaking change? You can of course add properties. That's also for REST. You can just add the property. But you can also rename properties. That's different because here, for example, you made a typo in temperature, and no worries, you can just fix it. As long as the number stays, the data is sent in the correct way. What you can also do is removing fields unless your code is not checking if there isn't rainy boolean, otherwise it will crash, of course. You can rename even the message of your thing. Adding and removing types is the same way because it's also using numbers. But never ever change the type of a property. So if you change a string to a double, then the byte array will become corrupt and it will not work. It will crash. How can you do versioning? So we already said everything can be packaged. Is like in Dart. You can actually. They say it's best that you have a version number in your package name. For example, here I can create a new version, but the disadvantage is that you then have to implement everything, even if some methods are not updated. So it's maybe better to just add the version number after your method call, and then have multiple versions and running on the same server. Why gRPC is more performant than others, or than REST? Yeah, we already talked about it. It's binary data, very small payloads. It's also using HTTP2 by default, while REST is sometimes HTTP2, sometimes HTTP1. And if it really has to go fast, for example, you want to send the position of your pointer, for example, if you, as a mouse, and you want to do every time a new REST call. Yeah, it will be very slow. While gRPC also supports streaming data, so you can say to the call it accepts this request, but it can accept it multiple times. So the server can receive the same object over and over again. The other way around, the server can also send data over and over again. That's very useful if you create a trading application, for example, like we are doing on the InvestSuite. When the price of Apple stock, for example, changes a lot, it just sends the data over the line, and it got changed. How do you validate your protospecs? Because every developer needs a validation in their CI code, but also on the development machine. You can make if you make things that does not work, it will check it. Buff is a tool. Here is the link that will validate all your protospecs. And then the idea behind gRPC is actually you create one spec and you generate code from it. You can generate code from it, and that code can be used as a client or as a server. So how do you generate code? One simple command. You have to install Protoc, of course, and then it will generate code. Maybe I can briefly show you how that works. Where are I created a demo project here where I created the protospecs of my weather info service. As you can see here, we all have lots of data, and then I have a command to generate the protospecs. And when we then look at the code, no, not here, it's generated code. doesn't look very nice, but it's there. You don't have to. You don't have to read it. Yeah. But no panic. It will work. Then maybe I can show a very brief tip. We found out now, after some months of coding, that every time you change a property, you add a property or you add a message, there is one identifier that is used in the generated code, that integer number that goes always up and up. I can show you. It's this one, S0. And if you have 100 messages, the one with a Z in it, the last one contains 100. So it means if you add something, all the numbers of all the files are changed, and you have a big merge request that says, oh, you changed a lot of code, and the next time you get merge conflicts. That's something they don't tell you. But in the end, you can fix it by actually generating the code just from every file at once. I mean, not at once, but every time I list all the files here and generate the code. Also a good one is, for example, I created a separate package for it. So I just created a folder with a pubspec YAML in it. It doesn't have to be a Flutter plugin, it's a Dart plugin. Added these dependencies, and the code will actually generate all these files, and that's also something I generate. And then you can start creating a client that uses this plugin, or a server that uses this plugin. Error handling. How do you do error handling? There is a very limited set of error codes that gRPC is giving you. They say it's enough, but of course, it's too limited. If you like to have more, there is another way. You can just say your response, for example, that you answer can be or the info that you requested, or it can be an error. And then your error model can be something you define for all your calls the same model, or for every call a specific error, because some can also be warnings or expected errors. Then to create a gRPC server, that's also possible in Dart. You have to depend on gRPC, and then I also add my reference to the generated code there. This is an example of creating a server. So starting maybe with a bottom server.create, you define your service is defined here. You can say or use gzip and so on, this port, and okay, that's done. Now you have to implement your methods. So the call that we defined in the protospec is in this class. This is from the generated code. You implement it, and here you can say, okay, just return the weather info with these objects. Very static web server, gRPC server, of course, otherwise not found, or even if I did not implement it, I can also return that. Demo time, small demo time. All right, very briefly, this one, I created a repository. I also shared it on my GitHub account, the server. Here, for example, it's this one. I think it's almost the same as we saw in the slides. Let's run it. You can run it with, should I run it? Where is my console? Okay. Is it readable? probably not. I can. Ah, it's here. Okay, so here we are in the server folder. Here in the bin, so here I'm using fem dart run bin / server dart. All right, listening. Okay, very small demo. Now we want to. We don't want to already start implementing the client and see if it works. And what you do if you implement the REST service, you want to debug it with Postman, for example. Tools to do it is actually, for example, Crea is a tool to do gRPC calls. You define, I want to connect to this server and I have these protofiles. And then it generates you this list. Yeah, you can also pass metadata and so on. And then you can test your call. Okay, let's try if it's working. Our server is still running, of course. This is Crea. Okay, let's do this call. Location ID ABC. Let's do yeah. No. I renamed my folder, of course. Good. Can I open it again? Yeah. How do you go? How do you go here to /opt? That Command L? No. 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 Command what? Ah, it's closed. Okay. I can move it maybe? No. Ah, here. It's this one. Crea config. This one. Let's try it out. Yeah. Okay. Okay, it works. Location not implemented. Now this one with another one. Okay, not found. That's expected. Our server works as expected. We can start with the client. No, other tools to do it is Bloom RPC, which is actually a bit older, doing the same, but I like Crea more of the advanced options that you have. For example, if you want to authenticate with your with an OAuth service, you can do it. I can even do an It's Me integration in Crea because it was using OAuth at the end. Here they only allow to add metadata, and you have to get the token and add it here. And then Postman also, I think only a year ago, they also added support for gRPC. But I think if you're familiar with Postman and you have an account on it, it's probably the way to go. I did not test it, but all right. Let's do it with the client then. It looks here. Okay. What do we have to do here? I created the Dart client just to show that it's also it don't have to be Flutter. Here you pass the same parameters, same port, local host. Yeah, here it's the example from the website I took here. I will maybe show it here in the code. Client. Okay. So yeah, what's happening here? You actually you instantiate this one. You instantiate first the client channel, then you instantiate this one. This is from the generated code again, and then yeah, you don't have to look at all those weird codes. It's just you can see here the methods are available, and you can just call them with an await. You can also pass some headers if you want, and then show the response. Let's try that out. That's the client Dart. I can also run it here. Here it's doing the call. It's getting the response and then exits. So the client Dart thing is also working. How do you do SSL pinning? Because that's also at least that's when it has to be very secure, like they say. You want to be sure that the certificate that the server is sending is really the correct one. The public key is actually correct. This is also something you can do. You have to define here, for example, you load the certificate. You have to override the channel credentials here, and then pass them also here. And then you have some other options, of course. Insecure is the one I chose now because I'm using localhost. But you can also use just secure, which is the HTTPS, the normal way. And if you really have to do certificate pinning, you can do it like this. It supports multiple certificates at the same time. So for example, if your certificate will be switched in 2 months, you can already deploy an app with the new one in, and it will automatically switch to the new one. That was my demo time. Now you're thinking probably, how does it work on web? Well, it works on web, but you need an envoy proxy or actually a gRPC web proxy. But I think envoy proxy is almost the only one that supports it, which is actually yeah, you have in the beginning you had the call, and the response was sending a metadata, your data, and then the actual response code. And that's something you cannot access in browsers. You can also only access the metadata if it's in front of the data. HTTP2, for example, they thought about, oh, we add it, and then browsers said, okay, let's also implement HTTP2, but they did not allow to access them. So it's not possible. What does envoy proxy do is that, and also even if you have very, very old browsers, it can fall back to HTTP 1.1 and it still keeps on working. What is not supported is the bidirectional streaming and also the client-side streaming. So that's not supported because you cannot make it happen on web. What is supporting is the other way around. If the server sends streaming data to the client, that is something that works. If you want to do tests, of course, you want to do tests. There are 2 possibilities. First is the thing I showed you. If you have a protospec and you can just create a Dart server and implement it with mock data. But then you try it out and you say, but during tests it's not possible to access the network. Okay, so how you're going to do that? It's actually with Mocktail you can, here's an example of how to mock the response future and the client, and then you can actually say when this call is executed, this has to be returned, and do your tests and so on. So it's possible. Then some gRPC links that are cool or interesting. It's my demo on GitHub. The package that you need to install on the client or on the server. This is the Envoy proxy that you need to use, but there is actually, if you check it out, there is if you use Docker Compose, it's only a one-liner to actually run it, and it will spin up the proxy server connecting to opening a port, and your client can connect to it. Also here I think there are like 300 awesome gRPC URLs on this repository, and then I think 2 days ago Postman also made a blog post about gRPC versus REST, which is really interesting to see. And then I can maybe also share still a demo of what happens when we want to use streaming. No, it does this one. Okay, so I made now I showed you the Dart stuff, and we can also of course do it in Flutter. I made a small demo. Let's first start the server. I always use, of course for the server it's best to use macOS build. Very small interface. When again we can, for example here, where is my CREA? Here, now I implemented, for example, a streaming data. Here, I will make it a bit. Can we still see it? Is there? So, for example, if you change the data is cloudy, it will send a new response to CREA. This is an example of a streaming data, and then we can also create a client that uses it. Where is it? Let's try that one. Yeah, okay, no problem. All right, so it's showing data from, what I took is, I looked in the Rive community to a demo of a weather application. So I just implemented it, and okay, it's raining, yes. And it's night. It's night. It's not. So there is a sun, and I can. It's rounded, of course, because nobody wants to. And hello, Flutter. Very small demo. All right. My last slides. Yeah, it's going on. Questions? Yeah.
When would you advise to use it in comparison to the rest or other?
Yeah, so basically if you want to stream data, then it's obvious. If you want to do like implement 2-3 calls, you probably can go with REST, I guess, because you have to do some setup, some configuration, Also on the server side, we have to be on the same, also using gRPC, while REST is a bit faster to set up. If you only have 2 weeks, you can choose REST or, of course, Firebase. If you have a bit more time, you can do this.
And have you read in all the information any comparison between a REST API being zipped and protobuf in comparison of size? Because I can imagine that
it's probably, yeah, but
API, that it would be
yeah. But at the end, gRPC only sends the data, even not the number of the data, and I don't think you can go smaller than that. Yeah, but if you zip it, it's smaller, I guess, indeed. But JSON still will always be a.
Even the parsing of JSON might take a lot of time as well.
Yeah,
so
maybe.
If you get really large JSON objects, it might be better if it's using binary format.
Yeah.
Depends a bit on how the generated code is generated. Not sure, did not dive into it. Yeah?
When you have a stream, does it always send the full object or only the property that changed?
Since the protospec is actually, normally every field is optional, so you can define your model like the weather objects info. It's possible to only send the data that is changed, but then you're at the client side, you have to maybe make your full object again or do the parsing. It's both are possible, but yeah. Yeah.
So this is RPC, but does it have enough of a buffer so that I can like implement like I don't know like a weather map and get like real-time data flowing in that is too fast for it to process? Does it have the capability to process a lot of data in a very short time, like really real time?
Yeah, that's definitely it. Yeah, I think there is no real other. It still has to be read in your Flutter code, of course, but I think it goes extremely fast. Yeah, not sure.
I think it also depends on how the generated code handles the eventual.
Yeah. But in the beginning I did some performance tests, like with streaming data, and it was really like, of course it was on my Pixel 7, which is a fast device, of course, but it was like reading like 8,000 messages or incoming calls in 1 second, which is, I think, over the network, which is already, if that's possible, I think it's.
That was an internal network.
Yeah, indeed, yeah.
Cool.
Yeah, I think then I tried over my Telenet account and network, and then it was 2,000 or. But anyway, it's probably if you have a small object, it's way faster, of course.
Yeah.
But yeah, the fact that it's using HTTP2 also makes it faster, that you don't have to create connections and so on. Yeah.
Since the proto buffers are really at the core of this communication, do you have any tips on how to organize this if you have multiple clients and multiple servers?
Yeah.
Tips. Yeah, the example I showed was only one proto file. At our company we have a complete set. Like in Dart, you also have packages, and I try to bring them together as logic as possible. An order service that gives you all the calls for an order service, and so on.
I meant more like on an organizational kind of way, like do you make separate repositories to share them? Do you keep things in
Indeed. So the proto files, I think it's best to have them as a separate repository. When you change them, you can already generate the Dart code and even the Scala code or the the C# code of the, I'm not sure, the code of the server actually, can also already be created and be packaged. So the client or the server only has to depend or change the version number of the created code actually. Yeah.
I think one fun one maybe could also be used to generate native plugins. We were discussing about generating Flutter plugins, and the actual implementation of it could also be used with protobufs. I think it could be generated from your protobufs, no? No?
Not, yeah.
So there is a package called Pigeon for generating meta channels. For example, but you could also use protobufs.
But not gRPC. Indeed. And then generate the code.
If you're already using it in your project, maybe it's easier to use that instead of something else.
Right.
So does not need to be used specifically for gRPC.
Yeah, they also say gRPC used protobufs. If you use it, the normal way, but using protobufs is not really necessary in gRPC, but it's the preferred one, so everybody's using it like that. But technically, it should be possible to use JSONs, but nobody's doing it. Already. Yeah. Right.
One last. When you design a server to handle all the have you run into the issue that the server gets overloaded and then you have to split it into two servers? For example, there's just too much load. I'm thinking about financial transactions going thousands and thousands over to one.
Yeah. So indeed,
because you have so much code, maybe it's better to split it up into different little parts.
In our company we have the gRPC server actually that can be load balanced, but that server is actually, if it's related to portfolio data, it goes to the portfolio service also via a gRPC protocol, and so it's not only one service that is doing everything. They also talk to deeper to other servers.
So you have a lot of little servers talking to each other with
Yeah. Like 60 or if everything goes calm, it's like 30, and otherwise it spins up.
Right, nice, thanks.
Right.
Alright, so we have stickers for speakers, so special stickers for speakers. They're shiny as well. So I will give one to Frey. So if you want one of the stickers, then you need to give a talk.
Yeah.